Hi, our names are Alexis, Kayla, and Emily, and we did our project on the physics of music.
So first we're gonna have a Chopin break because we're inspired by Dr. Coletta, and I think it'll get you in the mood for our presentation. All right, hope you enjoyed that.
So first we're gonna go over sound waves or waves of music, and then we'll get into the physics of music production in different instruments.
To start off with, sound is a longitudinal wave in which the medium vibrates parallel to the direction the wave travels. So you can see in the pictures below, the longitudinal waves are all parallel to the source, but the transverse waves show like kind of like a sine wave.
Sound is also a mechanical and pressure wave. So the mechanical wave is a disturbance transported through a medium. In this case, it's air and through the particle to the particle interaction. And then a pressure wave is a sound wave that has repeating patterns of high and low pressure through a medium.
So sound waves are created by oscillations, and these oscillations can come from a person's vocal cords or the oscillating portion of an instrument, for example, guitar strings. The speed of sound is about 340 meters per second, but travels faster in liquids and solids. Also, musical instruments all have different resonant frequencies, which is the oscillation of a system at its natural or unforced resonance. Resonance being the reinforcement of sound that occurs when you apply a periodic force at the object's resonant frequency. And harmonics, which are displayed in the picture, are waves with a positive integer multiple of the fundamental frequency. The original signal is known as the first harmonic.
Sound waves are standing waves, and standing waves are generated from constructive interference between waves traveling in both directions along a string or tube. And shown in the picture below, it says that standing waves are formed from two or more traveling waves that collide and are in tune with one another in such a way that their amplitudes add or subtract in repetitive ways. This is called resonance. And you can see the waves moving right and waves moving left.
So beats are a main accent or rhythmic unit in music or poetry. In physics, the two waves of different frequencies interfere, and then the waves cycle between constructive and destructive interference, which creates a beat.
So pitch is the quality of a sound governed by the rate of vibrations producing it, the degree of highness or lowness of a tone. So high frequency sound is a higher in pitch, and low frequency sounds have lower pitch. Sound wave compressions hit your eardrum one after another after traveling through your ear canal. So guitars have about 6 strings that are all the same length and tension, but the mass per length of each string is different, which creates the different frequencies. So the smallest mass per length has the highest frequency, and the largest mass per length has the lowest frequency and would be the heaviest string. And tuning a guitar sets the fundamental frequency of each string to its correct value. And you can see in the picture the oscillations of the guitar strings, which make the sound waves.
Okay, so now we're going to explain brass or woodwind instruments. So a mouthpiece is attached to like a long tube, and then air can go through that. And vibrations in the column or tube produces the sound. The length of the vibrating air can be adjusted by sliding the tube to increase or decrease the length and opening or closing the holes. The vibration of the lips against the mouthpiece produce a range of frequencies that match the column to the instrument and force the air into resonance vibrations. The source of these vibrations in woodwind instruments is different from the brass because the vibration of the wooden strip, the higher pitches as the straw, there are higher pitches as the straw is shortened.
For a piano, pressing a key results in a hammer striking a string from the underside of the string, and there are bridges that support the strings on one end, and the strings are tightened or stretched to a certain length to vibrate back and forth at a specific speed, and this specific speed is what produces the right musical note. And the vibrations from the hammer striking the strings results in vibrations being transmitted along the strings to the soundboard through the bridges. And the entire piano, and most importantly, the sound bar vibrates to produce sound. A loud sound resonates because the sound bar vibrates the air. So the strings vibrate the piano at the same frequency, and this amplifies the sound.